Okay, good day, viewers. Thanks for watching. In our today's class, I want us to learn set, S-E-T. So this is a broad topic in mathematics, but I promise to take them precept upon precept, lines upon lines. So first of all, I will let you know the concept of sets. After the concept of sets, we will learn types of sets with examples. After types of sets, we will learn um, we will learn Venn diagram and operations. I will do them separately because if I do them all in this one video, it's going to be it's going to be lengthy. So in order to conserve your time, I will do them separately for easy comprehension. Did you understand? So after that Venn diagram and operation, I'm going to make a separate video on application of Venn diagrams. Now in sets, now there are two types of problem in sets. One, we have two problem sets and three problem sets. I will show you how to know them. So anytime you see question on set, then you can tell whether that question is two problem sets or three problem sets according to the application of Venn diagram. So stay with me. Today, first of all, what is set? What is set? Set can be defined as the of objects collection of objects according to a well defined element or property. Now, there are set of spoons, set of pots, set of shoes, set of this, set of that. Do you understand now? And let me give you a simple example. For instance, if you hear that under 13 football players, what does that mean? It means that people who are not above 13 are the ones they are talking to, two of us. So now, under 13 football players, you won't find some 18 years old guy there or girl there. So that means it's a set of under 13 football players. Again, 5 years kids are found in Noiseville, or should I say primary school, are found in primary school. Which means that the set of people we can find there are from 0 to what? 5 years. Do you understand now? So, and again, what else I want us to know and learn today, that sets are represented in capital letter. They are represented in what? Capital letter. And there's a bracket we use in sets. That bracket is called curly bracket. It is called what? Curly bracket. How do you draw it? You do it like this. Do you see it now? They are called curly brackets. Hope you are following now. They are called what? Curly brackets. So this set, beyond mathematical knowledge, it found application in our day-to-day activities. Do you understand? It found application in our what? Day-to-day what? Activities. And basically, Set can be represented in two ways. They can be represented in what? Two ways. Basically, we can say that there are two basic ways of representing sets. One, there are two basic ways of representing sets. One, we can call them set builder or properties of what? Set builders or property form. Set builders and call them set builders or property what? Form. Now, this describes the content of, or should I say, this describes the set to their properties. Huh? How do we do that? For instance, when you have W, here, days of the week. W, days of the week. And you and I knows that the days of the week we have is Monday, Tuesday, Wednesday, Thursday, and Friday, right? Right? Good. So here, which means this can be represented as W Mondays, Tuesdays, Wednesdays, Thursdays, Fridays, Saturday, Sunday. Did you understand now? So that is it. The second one is we have what we call the roster or tabular or method listing. Do you understand now? Remember that this one, we said that this represents the element of the set. That this represents set builder property or property form. This represents the elements of the set common to their property. You can say here or property form. I did not complete it here. Did you understand now? Another thing we can use example, you can say y is equal to open bracket, you can say even numbers. Even numbers. Wait, do you know what even numbers? What they are, right? So we can also represent it by saying y, this bracket, can say x, s even number. Do you get? So, but if you come here and say even number between 0 and 10, huh? If you come here and say even number between 0 and 10, it's a different case. So what do you do in that light? Even numbers between 0 and 10. So we're going to say S even number 0 less than S less than 10. Did you understand now? Huh? So that is that on the basic ways of representing sets. Another thing I want us to go into is type of sets. Is what? Types of sets. We have many types of sets. We have infinite and finite set. You can call it infinite and finite sets. We have equivalence and equality sets. We have subsets and supersets. We have set of sets. We have power sets. We have comparability sets. But let's start with finite and infinite sets. If you are to start with finite and infinite sets, types of sets. Let's start with one. Finite, or that's a finite and finite set. Now, what I want you to understand here is this. This one is definite, but this one is what? Indefinite. Do you understand now? This describes set, a definite set, but this describes indefinite set. What do I mean? We have days of the week. We have months, right? Good. So example of final set. You say let W equal to days of the week. This is finite. This is finite set. Did you understand? Now, y, when y is equal to multiples of 2. This is infinite. This is infinite. Do you understand? Don't forget that I told you that finite has to do with definite something. What do I mean by definite something? Days of the week. We all know that in the week, the days runs from Sunday to what? Sunday to Saturday. That means Saturday is the last day of the week, right? But multiples of 2 are made because we have 1 to 1,000. No, let me just start with the blueprint of numbers, the basis of numbers. We have 1 to 1,000 and beyond. Even we have trillions, we have millions, we have thousands. So you realize that this multiples of 2 is infinite. But days of the week is definite. So that's why we call it what? finite. You do understand? uh, Another one is using, if you say, another example, other examples, x, let me not use x, p equal to moles of the year. Then maybe you say k equal to, maybe you can say odd numbers. Do you understand? You can say odd numbers, or you can say something like y slash y odd is odd. You can say it's odd number, or just say y slash y is odd. You get my point now? eh so another type of set we have is what we call equivalence and equality set. Equivalence and equality set. Number two is what? Now let's talk about this one first. Equivalence. um Now most students are confused on this particular type of set, equivalence and equality set. Why are they confused? When we say equivalent set, 5 bags of rice and 5 bags of beans is equivalent, but 5 bags of rice and 5 bags of beans is not equal. Did you understand that example now? Using analogy, 5 bags of rice is equivalent to 5 bags of beans. That's I. Second analogy, using what we all know. 5 basin, 5 basin of rice, 5 basin of rice is equivalent to 5 basin of beans. Did you understand now? I gave, what's it called, analogy. That is what you see every day as a concept to make this explicit, because I realize that most students are confused when it comes to equivalence and equality sets. So some mistake equality set to equivalence set, while others equivalent set to equality set. So I want you to understand equivalent set and equality set. So I'm going to clean this board. I'll clean here and clean there. Now I'll take it one after the other. Did you understand? Okay, equivalence. Let me start with equivalence. Equivalence. Don't forget we are still here. We are still in number two. Eh? Equivalence set. We have equivalence and equality set. Eh? Good. When you have W equal to A, B, C, D, and we have Y equal to 1, 2, 3, 4. You can say that W is equivalent to Y. Why? Because they have the same quantity. 1, 2, 3, 4. 1, 2, 3, 4. Do you understand? And the word equivalence is denoted, like, let me say, it is, we use plus sign. To remember equivalence, we use plus sign to remember it. Did you get? So that is the symbol for equivalence. That is what? Let me say, the symbol of equivalence is plus. Let me shade it. It's plus. So, which means W is equivalent to Y. Do you get the point now? So, saying that every member of W is matched to one and only member of Y. Every member of W is matched to one and only member of Y. We have A. How many A is here? 1. We have 1 here. Okay, let me give another example. Using, let me see, should I use name? Let me use name. Using name. Using names. I'm going to use Hausa Yoruba name and okay, let me say A. Now, with this place contain this. We have Shola. Shola is a Yoruba name, right? Adamu is Hausa name. Adamu. Emeka. Igbo name, my own name, Emeka. Then Yinka. Let's say Yinka. That is for A. Now B. We have something like this. B, we may have something like Fatima. Fatima. Obi. Musa. Musa. Akbam. Akbam. Did you understand? So, here now, one member, a name here is matched to another name here. Fatima, is that also name? Yoruba? It can be English name. I use Shola here. Musa, Akbam. Let's say Bola. Let me use Bola here to represent that Yoruba. Bola. So you can see that a member in A is matched to a member in B. Did you understand? That is equivalent to what? Set. Remember, we have Adamu, we have Musa, Hausa, we have Obi, we have Emeka, we have Akpa, we have Yinka. That is for equivalence what? Set. So look at it again. And before I before I continue on equality of set, don't forget we are still in number two. Now from the word equality, something being equal, you have one, two, three, four. And you have what else again? You have one, two, three, four, and you have three, two, four, one. They are equal. Huh? You say what? Okay. Look up. Here, we say that sets are equal irrespective of their order of arrangement. Here, sets here are equal irrespective of their order of arrangement. For instance, if you have that A is equal to 1, 2, and B is equal to 2, 1. Eh? Therefore, A is equal to B. We use this sign. And B is also equal to A. Why? Because I have 1, 2, and here I have 2, 1. Which number now? 2. Which number here? 2. Here, 1. Here, 1. Did you understand? Even if I have 1, 2, 3, and here, and I have 3, 1, 2, or 3, 2, 1, they are also what? Equal. Do you get that now? How are you doing? So, another example, this call this I. When you have A equal to 1, 2, 3, 4, and you have B equal to 3, 4, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4, and you have 3, 4, 1, 2. Eh? Okay, since I've used A there, let me use a different letter. Let me use Y and X. Therefore, Y is equal to X. So, this equality of set, equality is denoted by the symbol equal to, normal equal to sign, you know. Did you understand? It is denoted by the symbol equal to. Did you get? So the next one we have is subset and superset. Is what? Subset or superset. We may even leave it to study non-set. To study non-set. Now, where am I going to write this now? I have to clean. I don't need to clean this type of set. Is there need to clean? Just clean it. Okay, I'll just write ready. Non-set. None. That is N-U double L. None. We don't call it non-set. We call it what? Empty set. Soak this thing for me. Huh? You say what? You call it non-set or empty set? You call it non-set or empty set? So we call this one number three, right? Non-set or empty. Now, example, let me give you analogy now. Nobody is in the classroom, like 1 hour. Okay, school is in holiday, right? For instance. And now, you said nobody's in the classroom, but students are meant to be in that classroom. That is an empty classroom, right? Because in during holidays, classrooms at schools are empty because you cannot find anybody there, any student there, because that section is not school is not on section, right? Good. That is non example of a non-set. Let me look for another analogy. Nobody, listen, I didn't see anybody inside the church 2 hours after service. Do you get now? Which means that people were there, congregations were there, but 2 hours after service, everyone must have gone home. Hmm? So the church now will be empty. It is called what? Non-set. And it can be represented or denoted using this sign. Or use this. Eh? Or use this. That is for what? Empty set or non-set. So now, we use this for an enclosed set. We use this for an enclosed set. We use this for an enclosed set, and we use something like this for an empty set. Eh? These are the what you can use to denote them. Did you understand? Another example is this. The set of Nigerian students in secondary school below 5 years, is it an empty set? Eh? The set of Nigerian secondary school students below 5 years, below 5 years old. Eh? This is what? This is an empty set. Now, my question is this: why is it an empty set? Why? It is what? Why? No, no, no. It's not because it's infinite. It's not because it's infinite. Eh? Eh? You say what? Good. Why? Because there's nobody that is below 5 years in secondary school. This person self is not yet in primary school, not yet in primary two. Do you get? So it is an empty set. So if I want to represent this thing now, I can say where they have said it, this is an empty set. So that is, you say A, secondary school student below 5 years, eh, this is equal to empty set. Do you understand now? Is equal to empty set. Another example of empty set: Catholic women please. Catholic women priests. I can say I can say women are priests in Catholic Church. Yeah, is it empty set? Is it true? It's not. It is not. It is an empty set. It's not even because it's not true because women are not priests in Catholic Church. Based on the doctrine and foundation of Roman Catholic, a woman can never become a priest. So, example two: the set of Catholic women priests. Eh? Solution: this is an empty set. Eh? Reason: women can never become or be a priest in Catholic Church. Reason is that women can never become a priest or a woman cannot be a priest in Catholic Church. So this set now is an empty set. Is equal to what? Empty. Eh? Can I clean here? Next one, next example, example three. You can say A is equal to S slash X square equal to 4, then S odd. Here, the answer, here is -2 or 2, right? Neither one of the answers is correct. Eh? So therefore, it is an empty set. Did you understand? Good. The empty set. So the next one in our agenda is subset and superset. Is what? It is what? What's going to be there? What's going to be there? Number 4 now. Subset and close the door. Doctor, close the door. Subset and superset. Now let's talk about subset and superset. But first of all, let me focus on subset first. Subset. Now, I know this video might be a bit boring, but please exercise patience. Stay with me so that you learn the concept of this. So that when you start seeing questions, you understand what we are doing. Do you get? Now, subset. Subset simply means the element in A is contained in B. So let me not write much. Let me use examples to teach this. Example. If A contain 1, 2, 3, 4, and B contain 2, 3, 4. What are we going to do? We'll say that B is a subset of A. Now let me explain. B is a subset of A, meaning that we have 2, 3, 4 in B. Now in A, we have 1, 2, 3, 4. So 2, 3, 4 is found in A. I know that 1 is not in B, but 2, 3, 4 is in A. So B is a subset of A. Now let me give you a particular example. Therefore, which state? Anambra State. You're in Nigeria, right? Now, you are a subset of Nigeria because your state, or should I say your province, is in Nigeria. Now, if you are at Onitsha, let me say you are from Onitsha, for instance, and Onitsha is in Anambra State. You are Onitsha is a subset of Anambra State. Asaba is a subset of what? Delta State, because Asaba is in Delta State. Did you get the point now? So I have 1, 2, 3, 4 in A, and in B I have 2, 3, 4. So 2, 3, 4 is contained in A. That means B is a subset of what? A. Now, let's talk about superset. Superset. Before superset, I'm going to give you the symbol of subset in case you see that in question, so that you know the symbol of subset. The same way I gave you the symbol of empty set, non-set. Now, the symbol of this is A, B. This is a symbol of subset. This is a symbol of what? Subset. Now, superset. Let me put this thing now in block. That is something like this. Something like this. Did you understand now? The symbol of subset. I believe you've learned that. Let me just clean this thing. Did you understand now? So now, superset. Superset. Let me explain this thing using example 2. Remember that we have A, So we are going to say if A is equal to something of this nature, 1, 2, 3, 4, and B is equal to something of this nature, 2, 3, 4. Now, we can say that B is a superset of A. Can I explain? Superset is an opposite of subset. Is what? If you know what subset is, reverse is the case. So this is symbol for superset. This is symbol for subset. So if B is a subset of A, that means B is a superset of A. Did you understand? This one now is a superset of this. You can say A is a superset of B. Hope I'm not confusing you. You said? Mm. Is where the subset is doing what? It's cutting. Next is comparability of sets. Number 5. Comparability of sets. Now here, set is comparable when if or. Set is incomparable if and. What do I mean? Set is comparable when this if or is used. Then if and it isn't comparable. Now let me explain. When it comes to comparability of sets, that is where we need adequate knowledge of subsets. A set which is not a subset of each other is not comparable. It's not what? It's not what? It's not comparable. And for instance, a bag of beans is compared with Patasco. Patasco is a beans, right? Patasco is a type of beans, right? So a bag of beans is compared with Patasco or Mudu. But not compared with a bag of rice. Are you getting the point now? In the example we use here, A is a subset of B. So here now A is not comparable. So I see the concept of this comparability of sets. Is trying to strike a balance on this. So the next one I want us to look into is set of sets. What did I say? Set of sets. We need to look at set of sets. So here we're going to use Nigeria system of nuclear and extended family as a case study. All of us here can trace our lineage, right? All of us here can trace our lineage, right? Number 6. Now here we can see that this can be can be studied using nuclear and extended family system in Nigeria. Huh? For instance, what's your name? Chibike. Now you give birth to two sons. Eh? Obi and eh? Eh? Chiadi. Eh? You said it's Shaq. So we gave birth to Obi and Ifeanyi, right? Now, Obi got married and give birth to, let me see, Emeka and Sonto. Now Emeka got married and give birth to Chinemerem and Ndubisi. While Sonto also married and gave birth to Emmanuel, and speak is already here. Emmanuel and Chisom. Now, this is the this one now is sons. Sons. These ones are grandsons. This one's now great grand. If they continue now, we are going to have great grandsons. So this is set of sets. Do you understand now? So stating that everybody can be traced to a particular what? Lineage. Our lineage is traceable. Do you get? So now the next one is power of sets. Power of sets. That is number 7, right? Number 7 is power of sets. So here, power of sets, that is number 7. So here, let me use example to explain this. If A contains 1, 2, 3, this is going to be 2 raised power what? A. How many numbers are here? This is equals to 2 raised power 3. This is equals to 8. Let me explain. When you have y is equal to 1, 2, 3, 4 to n. This is 2 raised power y dot 2 raised power n, right? So what are we saying in essence here? What are we saying here? We're trying to say that in power of sets, the number of elements in the set, 2 raised to the power of 2 now, raised to the power of the number of elements in the set, which is 3. So let me assume that we have 8 numbers here. It's going to be 2 raised to the power 8. If you have 4 numbers here, it's going to be what? 2 raised to the power 4. So that is the concept of the power of sets. I don't want to speak much English here. So I want to use mathematics to explain this to you. So why I put this n here to infinity, that is, if you want to use formula, it is just 2 raised to the power n. So when you hear power of sets, I believe this example will enable you to understand this. Now let me solve another example. One, two, four, five, six. So this is 2 raised power what? Y, and this is equal to 2, 1, 2, 3, 4, 5. Raised power 5. And this is equals to what? 32. Am I correct? Call this I. Eh? Now, last but not the least is universal set. Is what? Last but not the least is universal set. Universal set. So let me complete it here. Number 8, we have universal set. We call this a fixed set or global set. It is used to represent the objects in particular. Do you get? So universal set now, it is noted something like this or something like this. Do you understand? And is commonly used in Venn diagram. So like I said, universal set is a global or a fixed set that has a collection of the properties in it. You do get that now? So this is all about what? Set. I believe you understood what I taught here. So I'm going to make another video on Venn diagram and its operation. After that Venn diagram and its operation, I'm going to make a video on problem set. Like I said initially that we have two types of problem sets. We have two problem sets and we have three problem sets. So I'm going to tell you how to know two problem sets and how to know three problem sets. So that is why you need to subscribe to my channel and give this video thumbs up. So here, the set under consideration here is subset of a fixed or global set. Is a subset of a fixed or global set. So if we are discussing, if we are to discuss engineering students at FUTO, we're talking about FUTO students at large, right? Engineering students at FUTO. We're going to talk about what? When I mean FUTO, I mean engineering students at Federal University of Technology, Owerri. So we are talking about what? Federal University of Technology, Owerri students at large. So this is a typical example of universal set. Do you understand? So that means every person in the Federal University of Technology Owerri can be the universal set. So universal set varies as our group of reference varies. Universal set as our group universal set varies as our group of reference varies. Remember I used a typical example of Federal University of Technology and I said that engineering student at Federal University of Technology, Owerri, which means when I mention that statement, it means that I'm referring to students of Federal University of Technology, Owerri. But I use engineering student as a what? As a point of contact, right? So that's why we say that universal set varies as our group of reference varies. So we're going to stop here, and please don't forget to subscribe to this channel and give this video a thumbs up. See you in my next video. So anticipate Venn diagram and its operations. Thanks for watching.